Hello, I'm going to work through whiteboard problem 8.1. So this is 2D dynamics. So we have a 500-gram model rocket. So I'm going to start writing my knowns down here. So mass is 0.500 kilograms. It's on a cart. It's rolling to the right with a speed of 3 meters per second. So the initial x is 3 meters per second. The rocket engine, when it's fired, exerts an 8-Newton thrust. So force of the thrust is 8 newtons. Your goal is to have the rocket pass through a small horizontal loop that is 20 meters above the launch. So y loop equals 20 meters. What is the horizontal distance left of the loop? At what horizontal distance left of the loop should you launch? So we want to find delta x. Okay, let's switch to our camera. We can draw out our visual here. So we have a cart, and on that is sitting a rocket. Okay, and then we have some distance away, up at 20 meters, is a little hoop that we're going to try and get the rocket to go up and pass through. Sounds easy enough, right? So we want to know what delta x is. We know this is the y of the loop. It's 20 meters. I'm going to define my coordinate axis right here. So this is my plus x, and this is my plus y. So if I just organize some of my other bits of information, right, I do have some, so I could say my x initial is 0. My x final, I don't know, I want to find that. The initial x is 3 meters per second, and my ax is 0. Okay, and then my acceleration in the y is going to be a little tricky. We're going to try and find that from the force analysis, but just in terms of the kinematics, y initial is 0. We want y final to be 20 meters. At least that's where we're going to stop the problem, right? The initial y is 0, and our ay we don't know. Okay, so it says find our delta x. We also need to find ay. And from that, we'll do our force analysis. Okay, so our motion diagram, right, in the x direction, well, it's going to be a parabolic, right? Our motion diagram is going to be going, no, it's actually going to be parabolic this way, right? Because it's going to have an acceleration upward. So it's going to be going constant in the x and then parabolic in the y. Okay, so look at the forces acting on our rocket here. We have gravity and we have thrust. Okay, so our free body diagram for the rocket. We have force of gravity going down, G, and if it's going to move upward, the thrust should be bigger, F thrust. Okay. So I think we have everything done here. So now we can move down to our down to here. I was just wondering if I should put important points in the motion, right? So it is actually going to go up like this, and we're kind of stopping it as it goes through the loop. That's where we want to go. Okay. Alrighty, start with Newton's second law. So we all know that and love it. It is the sum of the forces produces an acceleration, right? So net force equals mass times acceleration. Okay, so let's write these out as just as vectors, right? So we're looking at our free body diagram. We're not really caring about directions. Everything here, of course, is in the y direction, but even if it was x, we just sort of list our forces as the first step. So we have thrust plus the force of gravity. I'm still writing those as vectors, right, is ma. And now we can break them into our column vectors. So my thrust, if I look at my coordinate axis here, right, y is positive in the upward direction, so there's 0 component in the x direction, and there is positive in the y. I'm just going to start writing it as th. And then force of gravity, again, has 0 in the x, and it's negative force of gravity, which we could say is mg. And then we get our acceleration. Again, mass is a scalar, so it just comes in and multiplies both components of the acceleration. Okay. So this top equation, right, it's not accelerating in the x direction, it's just all 0. So we are going to solve for ay. So we get force of thrust minus mg equals may. Do our algebra, get that by itself. Ay equals force of the thrust minus mg divided by m. Okay, we could also just write that out, just as force of the thrust over mass minus g. So this is kind of the acceleration it would produce if it was just a thrust acting on that. Okay, let's go ahead and plug in. So we have 8 newtons divided by the mass is 0.5 kilograms. And then minus the acceleration of gravity, 9.8 meters per second squared. Okay, so that's 16 minus 9.8, we get an acceleration of 6.2 meters per second squared. Okay, so that's good. We have this one done, right? And now we want to find our, do our kinematic analysis. So, so I think what I'm going to do is just calculate the time it's going to take from based on the y equation to get up to 20 meters, because now I kind of know everything. I know the y acceleration. And then I'll use that time to figure out what the change in x position is. So I'm going to find t from the equation that gives me y as a function of time. Okay, so that is y final, right? Other books will write this as y as a function of time. It really is, at any particular time, it tells you what that y value is. So it's y initial plus by initial t plus 1/2 ay t squared. Okay, y initial is 0. B initial is 0. We want to solve for t. So I'll multiply both sides by 2. I'm going to get t squared is 2y final divided by ay. And t is the square root of 2y final divided by ay. Okay, so if you plug in those values, our y final is 20 meters. Our ay we just found, 6.2 meters per second squared. And I get that 2 is 2.54 seconds. And our units, right, meters cancels out with meters. We have 1 over second squared. 1 over 1 over second squared. That will give us second squared. Then we take the square root and we get seconds. Okay, so now we can find, use t to find the x. Okay, let's put a little here. This is kind of part 3. So x final is x initial plus v initial x, t plus 1/2 ax t squared. Ax is 0. We kind of knew that from even just kind of looking at it. To know forces in the x direction. The initial x, we know x initial we're saying is 0. So x final is v initial x times t. And we can plug in there, our v initial x was 3 meters per second. And our time is 2.54 seconds. And if we multiply those out, we get 7.62 meters. And that is that. Hope you had fun. Let's get shut this down now.